Okay, so on this problem, this is section 7.1. They're wanting us to solve the system by elimination. So this is different than substitution. This one is the elimination method. Really, I don't care on the homework or the test. You can do whatever method you want. I don't really care at all. As long as you get the right answer, I'm happy. I don't care how you did it. It's just sometimes substitution is easier. Sometimes elimination is easier. How do you know? Well, let me write a note about that. When, I think I need smaller print. When there are numbers, well, I should say that when no terms are 1x or 1y, use elimination. Yeah, that's the truth. So when none of them, see how none, if one of these terms was just like a plain x, which really means 1x, doesn't it? Or if this was just a 1y or just a plain y, then I could do substitution, because that would be easy to get that letter alone. So, but when none of the terms are 1x or 1y, go ahead and use elimination. Elimination will be easier. So how do we do elimination? Well, step one, multiply the top equation and the bottom to make either the x's or the y's opposite numbers. Well, one's positive and negative, the same number. So that's the first step. So you focus on either the x's or the y's. It doesn't really matter which one, doesn't matter at all. Like on this one, maybe I'll just do the y's. And you multiply the top equation and bottom to make either the x's or the y's opposite numbers, positive and negative, the same number, in other words. I'll say, let me give it a hint. Usually, multiply by the number on the other x or y. You usually multiply by the number on the other x or y. So for example, look at this plus 5y and this minus 2y. I want to make those the same number. Oh yeah, by the way, let me show you why. Let me just do it wrong at first. Don't write this down. Just watch me do it wrong. And then the reason we do it correctly will make more sense. Watch, don't write this down. This is not going to work. But if I don't, because you might wonder, why are you multiplying? What are you going to do? What are you going to make opposite? Why? Well, because of this. If you added them up right now, it's going to be what, 7? If you add these up, that's what we're going to do. We're going to add them in a minute. This elimination method is also called the addition method. It goes by either name. It's called the addition method. It's called the elimination method. You're going to add them up. What is going to happen here? What's plus 5y minus 2y? It's plus 3y. And this would equal what? 29. That did not work. Now, what do you mean that did not work? They added up just fine. What's the problem? Both, we want one letter to cancel. We want one letter to cancel. Nothing canceled. You see what I mean? We still have x and we still have y. Or I mean, even right here. Nothing canceled. We want one of the letters to go bye-bye. We can't really solve an equation where you've got both letters. We need one of these to eliminate. That's why it's called the elimination method. So that didn't work. So what's going to work then? We got to make them opposites before we add them so they'll cancel. So that's what you do. So I'm going to take this first equation. So 4x plus 5y is 33. Let me write it again. 3x minus 2y is minus 4. And so maybe I'll do the x's. Okay, so I'm going to multiply the top by negative 3 and the bottom by positive 4. Do you see what that's going to do? What is negative 3 times 4 going to be? Negative 12x. And what is 4 times 3 going to be? Positive 12x. See how I will make the two x's become opposites? Both of them are the same number. Both of them are 12, but one's a negative 12x and the other is going to be a positive 12x. That's what I mean by multiply by the number on the other x. So I multiplied, the 3, I went there, and the 4, I went there. But you got to make one of them negative, one of them positive somehow one way or the other, you got to make one end up being negative and one of them end up being positive. So, all right, what's going to happen from that? So then we get from there negative 12. Now this minus 3 has to go there and there. You have to multiply the whole equation, don't you? So it'll be minus 15. Why, right? Whatever you do to one side of an equation, you have no choice but to do the same thing to the other. Okay, and then the bottom one, same thing. This minus 4 is going to go to all three of those. And that'll be plus 12x minus 8y minus 16. Okay. Now it's going to work. You see it coming? Now we can add them up. So now when we add them up, so step 1, multiply top and bottom, and then step 2, add the equations to cancel one letter. So see how these will cancel, and this will become minus, what is that, 23y. This is minus, I don't know, what is that, 181, I think. Yeah. Minus 21, and now we can we can solve, can't we? Divide by minus 23. Boom. Y equals. Oh, that's just an ugly. I'm gonna try that on my calculator, see if it reduces. I don't think it does. I think it's just ugly. Yeah, it's just ugly. Ugly. So it's just plus 181, plus because the two negatives, right? Two negatives made positive. 181 all over 3. So there's the answer for y. Now we have to go back and get x. We have to go back and get the other letter. Now you have two choices at this point. One's a good choice and one's an easier choice and one's a harder choice. Basically, you have to go back and get x, so you could just plug that in. That's what we've done before, right? When you get your first answer, just plug it in. You can plug it in anywhere, you'll get your answer. But that's a difficult fraction to plug in. I mean, that's pretty messy. So let me make this suggestion. Step 3 now. Instead of plugging in a fraction, but if this was something else, this was just like 7 or something, I would totally just plug it in, because 7's not hard to plug in, but it's not. It's just an ugly fraction. Instead of plugging in an ugly, fraction, restart, cancel the other letter. What do I mean? Go back to the restart. So go back to the beginning. Let's write out the first equations again. 4x plus 5y is 33. And we had 3x minus 2y is minus 4. Now last time, notice I got x's to cancel, right? So this time, cancel the other letter, get y's to cancel. So what am I going to do? What do I got to do to make the y's cancel? What could I make 2 by multiplying? What could I make 2 and 5 both become? I could make them both 10, couldn't I? You see it? You see it coming? So I'm going to go, yeah, let's do that. Let's take this equation and multiply through by 2 in this equation and multiply through by 5, like that, right? And this 2 will go boom, boom, boom. And so then what are we going to get? 8x plus 10y equals 66. The bottom equation, same thing, the 5 is going to go boom, boom, boom. Whatever you do to one side of an equation, you got to do to both sides to keep the balance. So we'll get what? 15x minus 10y. See how those are opposites? By the way, I did not need to make one of them negative and one of them positive. I just left them both positive. Why? Because that one of them already inside the parentheses, one of the y's was already positive 5y and the other was already negative 2y. So I just multiplied both by positive and they came out naturally opposites. One's a plus 10y, one's a negative 10y. See how we multiply by the opposite letter? This 2, we multiply the top equation by the 5 from the top equation, we multiply the bottom equation by. Now we're in business, aren't we? See how nicely this is working out? Now we add them up. This is going to be what? 23x. These cancel, equals 46. Last step, just divide by 23. And x came out nice, didn't it? X is just 2. Did I mess up on y? Makes me think I messed up here on y. The fact that x came out so nicely makes me think that I messed up on the y. Let me go up and check it out, did I? 412 minus 8 minus 16 minus 15 minus 15. Looks good. Yeah, don't see any mistakes. It looks right to me. So our answer then, so we got x, we got y. So x is 2, y is 181/23. So the way you give your answer is you go one solution. X is 2, y was what? 181/23. So there's our x, y. So whenever you give an answer to a system, you give parentheses with a comma, the x, and then the y. So by the way, this method, let's recap what happened. So why did I do a different method here, elimination? Well, because they said so. But even if they didn't say so, I would have done it. Because why? Because there's no terms with a 1. If one of the terms is just like a plain x or a plain y, which really means 1x or 1y, then you can do substitution. You know, just get that x alone or that y alone and plug into the other equation. But if they all have numbers in front of them like these guys do, I don't want to do substitution. Why not? Because you'd end up having fractions. Do you know what I mean? Let me show you that real quick. If you took this one, 4x plus 5y is 33. If you wanted to do substitution, you'd have to get x or y alone, right? That's the first step in substitution. Get x or y alone. Well, that'd be a big pain. You jump that y to the other side, you have 33 minus 5y, 4x equals, then you divide by 4. There it is. There's x. You have to plug that in for x into the other equation. That'd be terrible. You see the problem? Now, last step, you have to divide by whatever number's next to x. You can make it one big bar if you want, but whatever, it's still a big pain because you got an ugly fraction. Then you have to plug that in for x into the other equation. That'd be terrible. See what I'm saying? So when there's numbers in front of all the x's and y's, it's easier to not do substitution. It's easier to do the elimination method. So get rid of that. So that's what I'm doing here. I'm doing the elimination method because there's numbers in front of all the x's and y's. And then how does the elimination method work? Multiply the top and the bottom to make opposites. So I looked and I said, okay, I started with the y's. You could have started with the x's. Or no, I started with the x's. It doesn't matter, whatever. And then I multiplied that one by -3, that one by +4 to make those opposites. One's a -12x, one's a +12. Then when you add them, that's why this is called the addition method. You add the two equations. That's step 2. Add the equations to cancel, to eliminate. That's why it's also called elimination method. The x's. Then we got y, finish solving for y. Now that was an ugly fraction. If that was a nice number like 7 or something, then I would have just plugged into the other equation. But because it came out so ugly, instead of plugging in an ugly fraction, it's an ugly fraction, 181 over 23, restart, cancel out the other letters. So I said, okay, I'm just going to restart. Bring these equations down again and just restart. This time, cancel the other. This time, make the y's opposites instead of the x's. I multiplied by 2 and by 5. They already had the positive and the negative, so I didn't need to change the signs. And then the y's canceled, and I added them again, and the y's canceled, and I was able to solve for x, which came out actually very clean. So there's our final answer, x comma y with parentheses and a comma in between. There we go.